Welcome to How Does GitHub Copilot Actually Work, Part 2. In the last video, we used stacks.dev to generate an automation tutorial that told us how to intercept network traffic. We booted up man-in-the-middle proxy and then triggered Copilot's autosuggest feature as well as its Copilot chat feature and looked at the differences. Today, we'll be doing the same thing, but with VSCode, the world's most popular code editor. Let's write a byte. Okay, so here we are with VSCode. And the first thing that we need to do is set the system proxy so that all network traffic gets routed through man-in-the-middle proxy. To do this, go to System Settings, search for proxies, and make sure that the proxy for HTTPS traffic is set to localhost and port 8080. Now we can fire up man-in-the-middle web. All right, it's running. Now we can trigger Copilot by typing. All right, looks like it worked. Let's see if we have network traffic. All right, here's the completions request. Let's copy that and see what it says. Okay, here's the entirety of the request, the completions request to GitHub Copilot. First of all, a lot of content, 156 lines with some of it wrapped. So that's a lot of data going back and forth, especially every single time you type. So let's see. The content is your role as an AI assistant is to help developers complete their code by assisting in editing specific sections of the code. Let's set wrap. Specific sections of the code marked by the code to edit and code to edit tags. Now this is interesting because this kind of looks like XML right here, but it's not. Notice the pipe. I think that's probably because XML or HTML is a very common thing to generate code-wise. And so to prevent any kind of parsing conflicts, they're including the pipe here. So that's probably going to be a pretty common pattern for LLMs going forward, while adhering to Microsoft's content policies and avoiding the creation of content that violates copyrights. Because asking AI to not violate copyrights, foolproof way to do it. All right, you have access to the following information to help you make informed suggestions. Recently viewed code snippets. Okay, so that's something that Neovim didn't have. There are code snippets that the developers recently looked at, which might provide context or examples relevant to the current tasks. They are listed from oldest to newest, with line numbers in the form of pound pipe to help you understand the edit diff history. So that's another interesting thing. LLMs, their line numbers, it has no concept of line numbers unless you explicitly tell it both supplying the line numbers and the formatting. I've tried before where it's like cite line 4 and not supplying line numbers, it will not be able to get it right. It's possible these are entirely irrelevant to the developer's change. Current file content. The content of the file the developer is currently working on, providing the broader context of the code. Line numbers in the form pound pipe are included to help you understand the edit diff history. Okay. Edit diff history. So it's able to figure out based on what you've been editing, where you might be going. So that's something that, again, Neovims did not have. So some additional context. Area around code to edit, the context showing the code surrounding the section to be edited. Cursor position marked as cursor. Okay, so that's saying exactly where the developer is within the file. Pretty important to generate for generation. Your task is to predict and complete the changes the developer would have made in the next code to edit section. The developer may have stopped in the middle of typing. Your goal is to keep the developer on the path that you think they're following. Some examples include further implementing a class, method, or variable, or improving the quality of the code. Make sure the developer doesn't get distracted, and ensure your suggestion is relevant. Consider what changes need to be made next, if any. If you think changes should be made, ask yourself if this is truly what needs to happen. What a sentence. Man, prompting at its finest. If you think changes should be made, ask yourself, but really though? Really? If this truly what needs to happen. If you're confident about it, then proceed with the changes. Always got to think twice, even AI. All right, steps: review context, analyze the context from the resources provided, such as recently viewed snippets, edit history, surrounding code, and cursor location. Evaluate current code, determine if the current code within the tags requires any corrections or enhancements, suggest edits. If changes are required, ensure that they align with the developer's patterns, and improve code quality and maintain consistency. Ensure indentation and formatting follow the existing code style. So trying to keep consistent code style, that's interesting. Output format, provide only the revised code within the tags. If no changes are necessary, simply return the original code within the code to edit and code to edit tags. There are line numbers of the form pound pipe in the code displayed to you above, but these are just for your reference. Please do not include the numbers of the form pound pipe in your response. Makes sense. That would be annoying to have to strip those out. Ensure that you do not output duplicate code that exists outside of these tags. The output should be the revised code that was between these tags and should not include the code to edit or end code to edit tags. So that's something that's interesting, is don't provide duplicate code. You could see that Copilot, without that, Copilot might be very tempted to think, oh, you must need this function, but that function may already exist in the file. So specifically giving instructions not to duplicate code, Uncle Bob would be proud. Here's the output format. Your revised code goes here. Notes: sorry, I can't assist with that for a request that may breach Microsoft content guidelines. Avoid undoing or reverting the developer's last change unless there are obvious typos or errors. Don't include the line numbers of the form pound pipe in your response. Okay. And so here's the user. So this is what that was the system message to provide the context. And now here's the part of the request that basically came from us. All right, recently reviewed code snippets. I don't have any, so nothing in there. Current file content. So first, a little bit of metadata. The current file path, we're going to say source app.tsx. That may be relevant for maintaining context for Copilot chat. Import use state, blah, blah, blah. Here's the, now here's the area around code to edit tag. So that's some actual context. And then here's code to edit. So this is saying basically where my cursor was. And then I don't know exactly how it's able to figure out where these tags go. That's probably the plugin that's trying to figure out what code is relevant to edit. So that's interesting. Now here's the area around code to edit and the end current file content. Okay, so this is interesting, the edit diff history. So as I was setting up this demo, I tried it once and then deleted it to see if it could still get it. It was able to figure out, this is not Git history, by the way. This is edit diff history. This is in VSCode. And we had a test, I wrote the test component, and it's writing that with a diff format. So pretty interesting. Copilot's probably able to use that to figure out, like, if you made this change, maybe I include something different if you deleted it, or just use it for additional context. Okay. Area around code to edit, code to edit. Awesome. Okay, so here's the more metadata. The model is Copilot NES XTab. Huh, I've not heard of that before. Type content, and here's the content. Oh, and here's the prediction. Okay, that was the request, so that's interesting. Huh. Okay, let's see what the actual response was. So that was the request. What's the response there? Whoa. So we're going to get the chat response. Dang. Okay, it's formatted. So there's a bunch of metadata in the response. I think that this is the streaming response. So you have all this metadata for like one character. How many lines are there? Yep, 2,500. That's not 2,500 characters because all this metadata takes up space as well. Okay, so here's the delta, and it looks like content is the thing that would make up the response. So let's see if we can't get kind of cute with ripgrep. Let's see, RG, or cat, it'd be cat. Yeah, there we go. So this is gonna just print out the content, and it's gonna print out the first capture group for that response. Let's see what we get. Okay, so it's kind of hard to parse your way through this, but you can kind of see what's going on. Like it's saying, and remember, each little bit of character is another iteration of the stream. So it kind of shows you how it was streaming in. I'm expecting to see test component. There it is, because that was what was actually predicted. Then div, class name. So like read the docs, more. Okay, so I think that the reason why there's so much more than the actual prediction is because Copilot, remember that in Copilot chat, we had the code to edit, right? Let's see that again. Okay, so this code to edit right here. So this entire thing may or may not be replaced. So it's not actually predicting just at the cursor. It's giving an entire block, and then Copilot's able to like figure out, okay, some of this may be different, some of it may not be. So to render it, it's probably doing a diff, figuring out what's being added, and then rendering that as virtual text, because this test component was what we were working on. Don't fully understand how there's test component. That would have been the one that I already accepted. But that kind of makes sense for why there's a lot more content here than just what was suggested. Pretty cool. Now let's see if we can do one where Copilot gets test component with the proper props. So I'm going to delete well, I'm not going to delete it just yet. I'm going to, no definition. Okay, there we go. Now I just went to the definition for my test component. This, by having the file open, will have it loaded in context. So now that the file is open, I wonder if Copilot is going to be smart to include the proper props. Maybe not. Interesting. So test component, even though I have the import statement, it's not quite as smart as Neovim's was. Neovim's included the open files as part of the context. And now with Copilot chat, even though I've opened test component, maybe I need to like save or something. It didn't get it right. So there's a little bit of variance in how VSCode's versus Neovim's plugin works. Let's see if we can do it with Copilot chat. Add selection to chat, add file to chat. Add terminal selection to chat. Interesting, okay. Okay, so let's ask Copilot a new chat. Please update the app.tsx with a test component entry. And notice that there's add context here. We can add test component to the context. So if I hit this with chat, it should add it to the context. Okay, so here's the response from GitHub Copilot. Notice that it got test component and it got the foo and the bar. So it was able to get the proper context that it needed. So we'd expect to see that in the request and response. Let's go and look at the requests and responses. So right here is the completions, this post request. And there's actually two that are very close together. Let's look at the timing to see if they ran in parallel or if the first one was used to inform the second one. I suspect that's the case, but let's look at it. So for the first one, we need to look at the end time, and then the second one, we need to look at the first request byte to tell us if they ran in series or parallel. So the response was complete at 12:55, 342, and 374 milliseconds. So remember 55, 342. And the second one started at 12:55, 547. So that is after. So it is likely that the first one actually was used to inform the second one. Let's see if we can figure out why. So this is the first request. Your helpful AI programming assistant. So this one looks pretty different than last one. You are a helpful AI programming assistant to a user who is a software engineer acting on behalf of the Visual Studio Code editor. Your task is to choose one category from the markdown table of categories below that match the user's question. Okay, so the entire point of the first question is to inform the second question. And if I had to guess, it's going to function kind of like a switch statement. Basically, there's going to be a set number of categories of requests that the user could want. And based on those categories, we'll probably inform the follow-up prompt. So that's kind of cool. So carefully review the user's question, any previous messages, and any provided context such as code snippets. Respond just with the category name. Okay, so the entire point of this response, or this request and response, is to fit the request into the category. So let's go to VSCode and see if we can't find this table a little bit better formatted. So here's the table, and here's all the categories. And you have a category name, category description, and example of the matching question. So it's kind of like the whole idea of a K-shot, where for each category, you describe what it is, and here's the example or matching question. So kind of cool that they're using a table and that the LLMs are able to understand that. It's a little bit more compressed than JSON. For JSON, you'd have to have like a key for each entry. So like category name would be duplicated all the way down, so it'd eat up tokens. And if you don't have to eat up tokens, then don't. Okay, so pretty straightforward with the categories. Now let's see what the response was. So this was the response. If I go here and I run that cat command again and do our little rip grep, the response, the streaming response, is add feature to file, which makes sense. That is kind of what we were going for. Okay, so the second one must be the prompt for what it would be if you added a feature to a file. Okay, so here's the messages. System, you're an AI programming assistant. And this looks awfully similar to the first one. So it could be that adding a feature to the file is the default for when you're doing the autosuggest, because this looks very similar. All right, here's the attachment. So the attachment, first of all, it's giving it an ID. And inside this tag, this is where it ends. So that's the entirety of the test component. So this is how it's able to get the context for the props. Now, please update the app TSX with a test component entry. That's what we sent to it. So the fact that there's a test component in the context, and we specifically reference, please update the app TSX with the test component entry, means that it has all the context it needs. Okay, so this one already has test component foo and bar, but the role is assistant. So I'm not entirely sure how it's able to figure out where this is coming from. All right, editing mic time. Let's ask Stacks to see what role assistant does in the context of GitHub Copilot. Turns out, VSCode remembers your chat history and uses it for subsequent queries. I must have already asked this question. But let's check the response. Let's run that command again. Okay, so here's the response. It's a little hard to parse again. TSX file path. Here's the file path. Development, Copilot analysis, app TSX. Existing code. So the existing, so it hasn't the existing code block like it was specified. Here's where the test component is being included, so that foo equals hello, bar equals 42. And then it ends the existing code. It got it right. Let's see how they formatted it. So existing code was actually meant to be a comment above and below. So the entire point of specifying existing code was that you don't need to do anything above or below that, only starting with the H1. So is it able to be insert at cursor? What does that do? That's wrong. But you can copy it or apply it. Oh, so applying the code block. Okay, so I just clicked apply and it did it twice. Whoops. But the first time it actually got it right. So it put it in the right spot. So how did it get this and properly apply it? Is there a request that it's going to use? So it doesn't seem to have used chat to apply the change, which kind of makes sense because all the information that it probably needed to do like a diff and apply was in the editor itself. So the actual Copilot extension probably did the application at line like 22. It said, okay, here's the existing code, here's the existing code. So figure out where there's H1, Vite, and React. Go through and see if you can figure out where this exists. Remember that there was some metadata that said where my cursor was. And it goes through and figures out where it belongs. And then has this nice little highlight that you can just accept it. That's pretty cool. I mean, Copilot in VS Code is pretty sweet. There's something to be said for being the most popular editor that, you know, maybe Neovim can't compete with. But still, when you do test component like, it doesn't have the context. So you win some, you lose some, I guess. Interesting. Well, that's it for now. To recap, we explored VS Code's GitHub Copilot integration and looked at both the autosuggest and chat features. The autosuggest feature was not able to supply enough context, but the chat feature supplied a ton of context, including what I've already typed, previous suggestions, diff history, and did a two-shot prompt approach where it asked to categorize the request into one of several different categories, and then use that to inform the next prompt. So as far as Neovim goes versus Copilot, Neovim was better at the autosuggest feature, but I think Copilot's chat feature with the first-class support for being able to apply your changes, plus the two-shot approach for categorizing your request, that was pretty good. So what do you think? What's the best editor? Do you vibe code? Any more videos you want to see? Like and subscribe for more.